grade 11 students, welcome to our video discussion about rocks and minerals. For today, we will be discussing about the formation of rocks, rock cycle, and the properties or characteristics of minerals. First, for the first part of our lesson, let us first define what are rocks. Rocks is any solid that is naturally occurring and naturally found on Earth. So what does it mean? It simply means that rock is any solid material that naturally exists in the Earth's surface. Not only that, they are also known as a consolidated aggregate types of minerals, meaning rocks were formed because of consolidation, compaction, and a combination of different minerals. Then, rocks may form from pre-existing rocks. How? How is it possible? It is possible because rocks can be transformed into one form by means of different processes, such as weathering and erosion, sedimentation, compaction, or by subjecting these rocks into extreme heat and pressure. We will be focusing on that part when we will be discussing about the rock cycle. And lastly, rocks just may contain just one type of mineral or maybe two or more kinds of minerals, meaning they can a certain rock may exist in a single form of mineral or crystal or may exist in two or more kinds. Next, here we have the different soil layers or soil horizon. For this, we have the O horizon, A horizon, E horizon, B horizon, C horizon, and R horizon. For A and O horizon, we have the organic and the surface soil. This is the topmost layer where animals and plants have grown. Like for example, the roots of the plants were found on the surface soil or what we call the A horizon. Next significant part of this horizon is the C horizon. Wherein C horizon, also known as substratum, we can find the groundwater. In connection with the rocks and the rock cycle, we have here the difference between magma and lava. What is magma and what is lava? Basically, magma and lava are both from molten rocks. But what is the difference between the two? When we talk about magma, these are the molten rocks that can be found beneath the Earth's surface, while lava is a molten rock that is found outside the Earth's surface when volcanic eruption took place. Next part are the types of rocks. So do you have any idea what are the different types of rocks? If you don't have any idea, come on, let's move to our discussion. First, in identifying the different characteristics of rocks, we can classify them into three major types of rocks. We have the igneous, sedimentary, and metamorphic rocks. First, let's talk about the igneous rocks. In terms of igneous rocks were formed out of hard and cooled magma or lava. Therefore, we have two kinds of igneous rocks. We have the extrusive igneous rock and the intrusive igneous rocks. What's the difference between extrusive and intrusive? From the word itself, ex meaning exit. Therefore, it is made out of lava, which can be found outside the Earth's surface. While intrusive igneous rock from the word in, what's inside? Meaning, igneous rocks were formed out of solidified or cooled magma that is found beneath the Earth's surface. Next is the three major category of sedimentary rocks. We have clastic sedimentary rocks, organic sedimentary rocks, and chemical precipitate sedimentary rocks. First, let's talk about the clastic sedimentary rocks. When we talk about clastic sedimentary rocks, they were formed out of weathering process. Wherein weathering process is the process wherein we are breaking down rocks into pebble, sand, or clay particles. While organic sedimentary rocks form from lithification from the remains of plants or animals that may be fossils, corals, or decayed plants or animals. From the word itself, organic, meaning organic sedimentary rocks were formed out of combination of a what? Combination of an organic material. And that organic material is just like what I've mentioned a while ago, such as fossils and animal remains. And lastly, the chemical precipitate sedimentary rocks. These types of rocks were formed when minerals dissolve in water. So what is the most common example of chemical precipitate sedimentary rocks? The most common example of this is the table salt or sodium chloride that we are using in our daily lives, isn't it? Salt were formed because of evaporation. By means of evaporation process, we can create soil out of the sea water. And that is an example of a chemical precipitate sedimentary rocks. Foliated and non-foliated rocks. We have, for foliated, there is a presence of platy surfaces or wavy alignments of lights, meaning you can clearly see or you can clearly observe a horizontal or a vertical lines with foliated rocks. On the other hand, for non-foliated, one of the main characteristics is that the absence of platy surfaces, meaning you cannot see any wavy alignments of light and dark mineral patterns. Instead, for non-foliated rocks, you may observe some patterns like dotted patterns or no patterns at all. But unlike foliated rocks, it is very observable the light and dark lines or alignment due to metamorphism. And that is the main difference between a foliated and a non-foliated rock. Let's take a look at an example of a foliated and a non-foliated metamorphic rock. Okay. Here are the illustrations of a foliated and a non-foliated rock. That ends our discussion for the three categories of rocks. Let's move to the rock cycle. Here is an illustration of the rock cycle. Follow me during our discussion by following the lines or the arrows presented in this illustration. First, let's start with magma. The rock cycle generally and typically starts with a magma or lava, isn't it? Igneous rocks were formed out of cooled and hardened magma or lava. When this magma or lava cooled or undergo cooling process, it will transform into an igneous rock. And if this igneous rock undergo weathering and erosion, it will transform into a sediments, isn't it? A while ago, we have discussed that weathering process is the breaking down of rocks into pebbles, sand, and other minerals. That's why it will turn into a sediments. Next, when these sediments undergo compaction and cementation, it will form into a sedimentary rock. Oh, have you observed that we have formed another rock with pre-existing rock, right? From igneous, we have formed and we have created a sedimentary rocks. Next, from sedimentary rocks, we can transform it once again into another form of rocks. But how is it possible? Or is it really possible to transform sedimentary rocks into another form of rocks? Come to think of it. Yes, it is possible. But how? It is possible by means of addition of heat and pressure. By means of heat and pressure, these sedimentary rocks will be transformed into a metamorphic rocks. And lastly, that metamorphic rocks, when subjected to extreme heat and pressure and undergo the melting process, this metamorphic rock will now go back to its original form, and that is the magma. So as you can observe, it is called cycle. Why? Because there is an unending process. It is a cycle because it starts with the magma and ends with the magma. And then from magma, it will start to another process once again. But as you can observe, there is another way or another process. From igneous rock, when you submerge igneous rock into extreme heat and pressure following the yellow arrow, you will have a metamorphic rock. Then, if sedimentary rocks, on the other hand, undergo weathering and erosion, looking at the green arrow, imagine if it doesn't undergo extreme heat and pressure. If you will subject it into weathering and erosion, it will go back to its original form, and that is being a sediment. Okay? Just like a metamorphic rock, when undergo weathering and erosion, it will also transform into sediment. So you can use the arrows in order for you to easily identify and easily distinguish and understand the rock cycle. For the next part of our lesson, we will be discussing about minerals. So what are minerals? We have here the minerals are the ingredients of rocks, or we can also say that rocks are made out of minerals. So what does it imply? It simply implies that rocks were formed out of minerals. Going back with our first discussion, we have discussed that rocks are consolidated and aggregate forms of one or two kinds of mineral. Therefore, we can create rocks out of combination of different types of minerals that we can find in the earth surface. Another definition of mineral is that it is naturally occurring inorganic elements or compounds with specific physical and chemical properties. So they are also naturally occurring, meaning they are not man-made. They are not synthetic. We can find them here on the earth by means of natural processes. Next, they have different and specific physical and chemical properties. So let us first identify what do we mean by these physical and chemical properties. First mineral property is color. They have said that color is the least useful property in identifying minerals. But the question is, why? Isn't it? It is very observable. Color is one of the easiest way in order for us to identify something. Just like, for example, if you have seen an orange fruit, you already have the idea that maybe that fruit is a pongkan, an orange, or a cat maybe, because we can easily classify them as citrus fruits. But in terms of mineral, geologists have believed that even though color is the most distinguishable properties of mineral, it is one of the least useful. Why geologists believe that color is one of the least useful property? Number one is because we can use the saying that colors may be deceiving. But why? Take a look at this image. We have two examples here. The examples coming from the right side is an example of a copper, while the image on the left side is an example of a gold. They have the same color, but they made out of two different materials. That's why color may be deceiving. We cannot say that, for example, if mineral A, B, C, and D are red in color, we cannot say that those minerals came from one family or came from one variety. Just like the second example. Okay? You can see that they are black in color, brown, crystalline in form, or very transparent, pink, or purple. Even though they have varieties of color, still they are made or they have derived from one variety of quartz. Did you get it? Meaning, Even though rocks or minerals exist in the same color, they may not be, or they may not originate from a one family. While if while on the other hand, some minerals or some types of minerals, just like for example this one, exist with the same kind but with a different color. That's why color is one of the least useful properties. Okay? Next. Second one is streak. Streak is the color of mineral in powder form. We can use this one in identifying the real properties or characteristics of a mineral by means of streak test. What is a streak test? A streak test can be done with the use of a streak plate. If you're familiar with the one of the famous TikTokers from the social media, the one that is using a streak plate in order for her to test the credibility of a certain product, if it is a legit gold or silver, a female TikToker is wherein one of her famous line is i-flex ko. Ayan. That specific TikToker is uses a streak plate. A streak plate in order to test a mineral or a product or a compound property. Okay? A streak plate is just like a black plate wherein if you have a mineral, like for example, this is your streak plate, and this is my mineral or my stone, I will just rub that stone into my streak plate in order for me to perform the streak test. And then with the plate, you can see the remains or the powdered form of that specific mineral. Because sometimes, even though its outside appearance may be green in color, but sometimes there are minerals that its true color or its color in powder form is different from what we can see with our naked eye. That's why the streak test is much more reliable compared to the color test. And number 3, we have luster. What do you mean by the word luster? When we talk about luster, this refers to the properties or characteristics on how these mineral reflects light. Are you familiar with the properties of light or the way on how objects transmit or reflects light? We have 3. We have transparent, translucent, and opaque. Okay? Talking about the transparency of light, when we talk about transparent, it emits or transmits most of the light. It's very clear. It's very transparent. Light can pass through. Well, when we talk about translucent, it is somehow blurry. Just like, for example, window jalousie. They can transmit light, but in a small amount. And lastly, when we talk about opaque materials absorb light, meaning they cannot absorb any kind of light. Meaning, once light strike an opaque material, just like a solid concrete floor or a solid concrete wall, rather, it will absorb light and it will not reflect any single light. And that is in connection with luster. We also have different kinds of minerals that exhibit these characteristics. We have metallic, submetallic, and non-metallic luster. Okay, so take a look at the images below. One of them is a submetallic in a metallic mineral, while the other ones are non-metallic mineral. Take a look at the images on the right side. We have the red and the white stone. The red and the white stone exhibits non-metallic property, meaning they cannot transmit light. Instead, they are absorbing all the light. Right? Instead of reflecting light to a surface, there is just a formation of a shadow because they block all the lights that they absorb. While on the other way around, on the left side, take a look at the silver and the gold mineral. They're classified as metallic. It's either submetallic or metallic luster because they can transmit light. Okay? They can reflect light. They are somehow transparent or translucent. Number 4 is hardness. Hardness is the ability of a mineral to resist being scratched by means of the scratch test also. What do we mean by the word resist? When we talk about resist, there is a resistance. There is an opposition to something. Meaning, if the mineral is if the mineral is hard, it has a higher tendency to resist abrasion or to resist scratch. We have a question here. If mineral A can scratch mineral B, what does it tells us about the relative hardness of each mineral? Is there any relationship between the two? Okay, let's create an example. For example, this is mineral A and this is mineral B. Then, if I will be scratching mineral A from mineral B, and then after scratching mineral A from and mineral B, I have observed that mineral B has many scratches, while mineral A has only a few scratches on it. So what does it mean? Does it tell us something about the relative hardness of these of mineral B and mineral A? The answer is yes, it tells us something about the relative hardness. Because comparing these two minerals, if mineral A resists abrasion and mineral B accept the most abrasion, meaning mineral A is harder compared with mineral B. Because mineral A resists more of the abrasion or scratch. Right? So it simply tells us, or it simply means that when we are comparing different minerals by means of scratch test, we can tell which among the two is hardest by just merely looking which among the mineral resists abrasion. Okay? And that is for hardness. Next, number 5. Number 5 is fracture and cleavage. So what is fracture and cleavage? Okay, let's read the definition of fracture. Fracture, mineral breaks unevenly or irregular, while cleavage is the tendency of a mineral to break evenly along its weakest plane. So, from their definition, we can say that fracture and cleavage have one in common, and that is the characteristics or the tendency of a mineral to break. But are they the same or not? Let's think of it. First, according to our definition, we have fracture. It tells us that mineral can break unevenly. And when we talk about unevenly, meaning there is no specific and no regular patterns. It will break in any form. It can break horizontally, diagonally, vertically, or in any manner. While on the other hand, cleavage may break mineral evenly. It simply means if it's broken, if it's meaning if it breaks horizontally, the rest will follow. Right? What is the clear evidence of this one? Let's take a look at some illustrations below. Let's take a look at some illustrations on the next slide. Okay, take a look at these examples. We have fluorite, halite, and calcite. As you can observe, they have break in a regular pattern, and that is cleavage, because breaking in a regular pattern talks about cleavage. Take a look at fluorite. It breaks in a very smooth, fine, triangular shape, while halite breaks in a cube-like shape. And observe about calcite. It breaks in a regular pattern or a regular manner, just like a rectangle box, right? That is cleavage. But when you talk about fracture, it will break unevenly. Just like, for example, you have a very big piece of rock and then you throw that rock or you hit that rock with a very strong force, it will break unevenly without knowing what will happen to that rock. But when you talk about cleavage, you already have the expectation on what will happen or how will the rocks will break, because there is already a pattern, and that pattern is because of the weakened force in that rocks. Next we have crystal form. Another characteristics or properties of mineral is that it tends to form crystal, wherein we can identify this crystal by means of the different shapes, because they also exist in various shapes. We have isometric, tetragonal, orthorhombic, monoclinic, triclinic, hexagonal, and trigonal. Okay? Looking at the illustration and at the example, how can we identify the size, the shape, or the mineral or the crystal form of different minerals? Take a look at the axis. We can identify if it is isometric, tetragonal, or triclinic by looking at the angles or the axis. And because from isometric to trigonal, there is a specific and exact angle or axis from A, B, and C. The number 7 is specific gravity. What is specific gravity? It talks about the ratio of density of a mineral to density of water, meaning we can test the specific gravity of every mineral by comparing it to the density of water, because specific gravity talks about the ratio of the mineral and the ratio of water. For example, this is the density of my mineral, and this is the density of water, which is 1 gram per cubic meter. We'll be comparing the ratio between this mineral and the water, and that is specific gravity. Okay, question here. If a mineral has a specific gravity of 5, that means it is 5 times dense as water. Why? Because water is only 1 gram per cubic centimeter, and that mineral is 5 gram per cubic centimeter. Therefore, it is really 5 times as dense as water. What does it tell us about density and specific gravity? If a mineral is more dense, or if a substance is denser, it tends to what? It tends to settle down. Okay? It tends to settle down at the bottom. Why? Because of its higher density. But if a certain mineral or a certain compound is much more, but if a certain compound or a certain mineral is less dense compared to water, that compound will surely float. For example, we have rocks and water. If you will combine rocks and water, rock is very dense. For example, rock is 5 gram per cubic centimeter, and water is only 1 gram. Comparing their density, rocks will surely what? Rocks will surely submerge into water. It will settle down at the bottom. But on the other way around, oil, which has a density of 0.93, will float. Why? Because of its lower density, right? Since oil has a lower density compared with water, when we are mixing oil and water, we can easily observe that the oil floats with water. And that principle lies under density. Therefore, we cannot mix oil and water because of their polarity of molecules. Not only that, but as well as when it comes with their density. To have other types of mineral properties. We can use acid test. Acid test, like for example, we are putting hydrogen chloride on a rock and observing it will, if it will be eroded or if it will form any bubbles, something like that. Next is magnetic. Magnetic, we are using a magnet in order for us to attract that specific kind of rock. Just like for example, gold. For example, I have a gold necklace and then I will use a magnet. Then I will try if my gold necklace will follow the magnet or will it stick to my magnet? Okay? For example, situation A, my gold necklace is stick with the magnet. So what does it imply? It simply means that my necklace is not a 100% or not a synthetic gold. Right? It's not a pure gold. Meaning my necklace may be made out of other mineral, just like for example copper, right? Because true gold will not stick into a magnet. A true gold doesn't have any magnetic characteristics. And then last number 3 is by means of taste. An example of this is halite, wherein halite is one of the wherein halite belongs to an example of a table salt. Okay, that ends our discussion about the characteristics and properties of minerals. For our activity for this lesson, we have the rock cycle song. So for this one, we will be singing the rock cycle song with a tune of Row, Row, Row Your Boat. I will be singing this one, and make sure to follow me as I sing using yours lyrics on your printed module. Come on, let's sing. Sedimentary rock has been formed in layers, often found near water sources fossil from decays. Then there's igneous rock, here since Earth was born. Molten lava cooled and hardened, that is how it's formed. These two types of rocks can also be transformed. With pressure, heat, and chemicals, metamorphic they'll become. Once again, I am Ma'am Camille Manaloto, your Earth and Life Science teacher. Thank you and good day. Teacher. Make sure to like and subscribe with our YouTube channel for you to be updated for our next video. Thank you and good day.